Alrighty, guys. So now we're going to talk about word equations. These are not that hard. It's just balancing equations from words. It's a combination of naming along with balancing. Okay, so word equations have to start with words. So the first thing you got to be able to do, right, is be able to um, take a name and write the formula correctly, right? Crossing charges or using the prefixes, depending on what kind of formula you got. So you have to go from name to formula. Then once you have all those formulas, you have to balance it just like you've been doing on your balancing PL. So it's not that much more, and it's not anything new. It's just combining two things. Um, so the thing about word equations is that you really need to be careful of our diatomic molecules. So let's just recall what a diatomic molecule is, right? A diatomic molecule is two atoms covalently bonded together. That's how we get that name. And remember that there's only 7 of those. And there were different ways we could remember those 7. I like that they are genuine. Genuine helps us know when we read the word, if it ends in gen or ine, that it's diatomic, that it's going to get 2. Miss Smalling, right, likes Brother Honcliffe to remember our diatomic molecules. And also on our periodic table, they happen to form, right, a 7, nitrogen, oxygen, fluorine, right, chlorine, bromine, and iodine. But if you count those, that's only 1, 2, 3, 4, 5, 6. Oh, hydrogen is also in that far corner, far, far away. But these do look like a 7 for the 7 diatomic molecules. Which means if I read the name oxygen, you have to recognize that it ends in gen, that when I write my word equation, it has to be O2. Otherwise, it's just going to be incorrect, right, on our balanced equations. So just be cautious. And so we're going to do a couple of examples of word equations here. Our first one is going to be kind of simple, right? We're going to do, well, let's do magnesium. This is really simple now that I've said the word magnesium. Let's make it a little more complicated, right? Okay, let's do magnesium sulfate is going to react with some, let's do iron 3 nitride. And in our word equation, that's going to produce, I need the next line down, sorry, some magnesium nitride and some iron 3 sulfate. So if this is my word equation, it's like 4 namings and then balancing, right? So we're going to start with our reactants. Let's start with magnesium sulfate. Magnesium sulfate is Mg with a +2 charge. Sulfate is SO4 with a -2 charge. Those are even, so I'm not going to do anything, right? I'm going to react that with iron 3 nitride. So iron has a +3 because the Roman numeral told me so. And nitride is just a nitrogen with a -3. Those are nice and even and balanced. Yay. That's going to produce magnesium nitride. So I already know that magnesium is a +2 and nitride is a -3. But now those aren't even, so I'm going to have to cross my charges. That's 3 comes below and that 2 goes there. And that's going to also make iron 3 sulfate Again, I don't have to relook it up. I've already written it down once, but I still have to cross my charges, protect my polyatomic, and then put my subscripts. So now that we have named all four of these things correctly, the last step is to balance, right? And we can see that I only have one magnesium here, but I have 3 magnesiums here. So I'm going to put a 3 out front. That gives me 3 sulfates, which is okay because I have 3 sulfates. Iron has 1 here. There's only 1 iron, but here there's 2. So I need to put a coefficient of a 2 out front. That gives me my 2 irons to balance. It also gives me my 2 nitrogens, which is fine with me because I needed 2 nitrogens. So this balanced equation is a 3, 2, 1, 1. Okay. Let's try another one. Let's do aluminum iodide reacts with chlorine. And that's going to produce some aluminum chloride and iodine. So in doing this word equation, right, I'm still going to treat them like I'm naming, right? So let's start with aluminum iodide. That is Al with a +3 charge. Iodide is iodine with a -1 charge. So I need to cross my charges down, and that is AlI3. Then I have chlorine. Chlorine ends in INE, so it's not just Cl, it's a diatomic molecule, it's Cl2. That's going to produce aluminum chloride. Al still has a +3. Chloride has a -1. Remember that diatomics are only diatomic when they are alone. This is not genuine. It ends in "ide," right? So this is chlorine with a -1 charge. Chlorine by itself gets a 2. Here, this chlorine is satisfied his octet by taking electrons from aluminum. So his ending changes. He is no longer diatomic, right? Iodide was a -1, but when I have iodine, now he's alone. Iodine is not found alone in nature. He will bond to himself and become a diatomic molecule. Okay. Now I'm going to have to balance this, right? I've got 1 aluminum and 1 aluminum. Well, that seems fine. I have 3 iodines and 2 iodines. So this is a 3-2 problem. I can't make 3 equal 2, and I can't make 2 equal 3. So I'm going to have to make them both be 6. So I'm going to put a 2 out front here and a 3 out front here. But now I've changed my aluminums by doing that, so I need to put a 2 for my aluminums here. That now gives me 6 chlorines on this side of my equation. So on my reactant side, I need to put a 3 to balance that. Okay? And then one last example. We're going to do tricarbon hexahydride reacts with oxygen to produce carbon dioxide and arenospace and water. Okay. So in our last example, right, we've got some prefixes. That's nice. So I've got tricarbon, which means I need 3 carbons. And hexahydride means I need 6 hydrogens. That's going to be reacting with oxygen, so that's O2. That's going to produce carbon dioxide, which I know is CO2, and water, which I know is H2O. that's a pretty easy go into words. Always be cautious when something seems easy. That means it's going to get harder. Balancing this one is going to be slightly tricky. I'm even going to switch to a pencil because it's going to require, for me, erasing, right? So if I have 3 carbons here, I want 3 carbons here. And if I have 6 hydrogens here, 3 times 2 will give me 6 hydrogens there. The problem then comes in when I'm counting my oxygens, right? 3 times 2 is 6, and 3 times 1 is 3, and 6 plus 3 is 9. I ask myself, what times 2 will give me 9? I have some students sometimes that tell me it's 4.5. You can put 4.5 there, right? Or if you can't think like that, if you say nothing times 2 gives me an odd number, you're going to do the same thing, which is multiply through by 2's. And when I do that, that's going to fix my odd problem, because anything times 2 becomes even. It's very magical, right? So if I stick a 2 out front, I am then going to need to erase, right? Now 2 times 3 is 6 carbons, and 2 times 6 is the same as 6 times 2, right? Hydrogens. But now I've got 6 times 2 oxygens here is 12, and 6 times 1 is 6, and 12 plus 6 is 18, right? Because when we double 9, right, we doubled everything, so we doubled literally all the numbers. I know that 9 times 2 gives me 18. So I get 18 oxygens on this side and 18 oxygens on that side. Okay. So it is balancing, but it's from words. And so it's really the same thing that we've been doing. Good luck on your PL.